Paul Mann, Chairman and Chief Executive of ASP Isotopes. Really good to have you here in the Bryanston studio in Johannesburg. Do you visit South Africa much?
Yeah, and I've probably spent about half my year here this year, so quite a lot. And I'll probably spend half of next year here as well. I live in America. I'm from England originally, but live in America now. And we have a South African business, so we spend a lot of time here.
We're going to talk about your South African business, ASP Isotopes, which has just been listed on Nasdaq, or just had an IPO on Nasdaq. But your own background, are you an engineer? Are you a scientist? Are you an analyst?
Yeah, I guess all of the above. So I studied chemical engineering at Cambridge many years ago and started off in science, but then moved into more financial industries, investing. So I worked for 11 years at Morgan Stanley in London and then New York. Then I moved to invest with George Soros for about 4 or 5 years, running sort of a healthcare book. And then I moved to Highbridge Capital, where I managed a long short book of investments. And more recently, I started up this company, ASP Isotopes, and it's a really exciting opportunity, and it kind of crosses both chemicals and healthcare. So it kind of, I fit it quite well.
And a listing on Nasdaq, that brings all kinds of restrictions on what we can talk about today, presumably.
Well, it does and it doesn't. We can talk a lot about the business and what we've done in the past, and and the kind of industry we're in. I won't make any financial projections or whatever during this interview, but we can certainly talk about how exciting the opportunity is here and what we're doing.
Why Nasdaq, or why not, say, the London AIM market or even Johannesburg?
Yeah, so we're a Delaware incorporated company, and most of our investors are US based. I think it's easiest to raise capital in the US, and I've spent the last sort of 10, 15 years dealing in US equities, so it was just a natural choice for us.
Okay, so there's a South African business, which is a high-tech science isotope-related business. How did you find it?
Yeah, so the opportunity got presented to us a couple of years ago. The South African scientists had run out of money while they were trying to build a very high-tech isotope enrichment facility. And so we took a look at it, and I understand the industry very well. I understand the end markets very well, and I recognize this could become a really interesting company if we put some more capital into it. We restructured it slightly, and so we did that. It took about 2 years to do. And I guess we actually incorporated the company 13 months ago in Delaware. We raised quite a lot of money from US investors, and we've invested that money in South Africa into our manufacturing plant, which should be mechanically complete, in end of the year, January, that kind of time frame.
And what plant is it?
So we actually have 2 plants, both in Pretoria, South Africa. The first plant enriches molybdenum 100. That's a very special metal. It has applications in the healthcare industry. The second element we will enrich is carbon 14. That has uses in agrochemical and pharmaceutical developments. These are very, very specialist chemicals, priced at thousands, or in some cases tens of thousands of dollars per gram.
So maybe we should rewind a little bit, and you can tell us what isotopes actually are, because my understanding from talking to your colleague Hendrik was that the rest of the world spins a cylinder to get the gases to change their format into isotopes, but he worked out how to spin the gas rather than the cylinder itself. So it sounds like looking at a problem from a completely different angle.
Yeah, that's right. So what isotopes are basically the same element or the same chemical, but they're slightly different. They've got a different number of neutrons inside the nucleus. And that means they've got a slightly different mass or a slightly different weight. And when you think about, let's take a packet of M&Ms, for example, lots of different colors of M&Ms. If you shut your eyes and tasted them, you wouldn't recognize the difference between a blue one and a green one and a red one. But you can separate them out when you can see them. Now, that's not quite so easy with an isotope. We have to separate them out according to their mass. And so we spin them very fast. And the heavier ones separate from the lighter ones as we spin them. When we've separated them out, then these isotopes have certain properties that we can then use for very special industries. Now, our technology, when you think about a centrifuge, you have this huge tube that spins very fast. They cost a lot of money to build. They're very complex to build. And things sometimes go wrong because there's lots of moving parts on them. in our technology, the tube is stationary, it doesn't move. We spin the gas inside the tube. And that has a number of advantages over the traditional centrifuges. First of all, the plants are a lot cheaper to build, a lot quicker to build. We can build a small scale plant for very specialist isotope in not a lot of time at all and not a lot of capital either, compared to a centrifuge that costs billions of dollars. So there's a number of advantages. Also, we separate light isotopes better than a centrifuge will. Centrifuges don't work when the isotopes get extremely light. We actually prefer light isotopes to heavier isotopes, and that has some applications in certain industries as well.
So just take us through those applications, particularly on the two plants that you have in South Africa.
Yeah, so our first plant, our biggest plant, is from molybdenum 100. And I said that'll be mechanically complete around the end of the year, January, that kind of time frame. And molybdenum 100 we expect to get used in the healthcare industry. So when you dig molybdenum out of the ground, about 9% of it is the 100 isotope. The rest of it consists of the 98, 97, 96, and other masses. And we take that 100 isotope up from 9% up to 95% or above. And then you can put it into a special machine called a cyclotron or a linear accelerator, and you can convert it into a product that you use in SPECT scanning, which is the most common radioisotope used in the healthcare industry. It's about, the molybdenum 99 market is about a $3.5 billion market. And so we'll be competing to take market share from that market.
Because it's even better in that application.
Yeah, we believe so. It has a number of positive attributes versus molybdenum 99. So molybdenum 99 is currently produced in 10 nuclear reactors around the world. This product, the molybdenum 99, it halves in value every 2.5 days. That's what's called radioactive decay. So you're trying to get this product from a nuclear reactor, typically in Eastern Europe or somewhere not in a common country for the Western world, and you're trying to get this product to a hospital when it's halving in value every day. The supply chain is very complex. It's quite common to have massive outages. In fact, the FDA last week put molybdenum 99 onto its drug shortage list. South African pharmacies received a letter a couple of weeks ago saying there simply isn't any Moly 99 right now. The world has run out of it because 2 reactors have shut down. So the supply chain has been fragile for years, and actually 9 of these 10 reactors will shut down between now and the end of the decade. So there's a supply shock looming. Now, our molybdenum 100 is shelf stable. You can FedEx it around the world. You can keep it on the shelf for as long as you want and take it out and use it when you want to use it. So it solves a lot of the supply chain issues currently in the marketplace.
Molybdenum. It's a tough one
to pronounce. That's right.
But it's a chemical. It's an element. Is it on that element?
It's on the periodic table. That's right. You dig it out of the ground, and it's used for many applications, such as enhancing metals and so forth. Yeah, there's lots of applications.
So as you put it through your isotope machine, it actually enriches it, and the 100 versus the 99 means it's slightly heavier. Is that correct?
Correct. Yeah. So the 99 isotope is not stable. You don't find it when you dig something, when you dig Moly out of the ground. It's not in that bucket.
Moly, I prefer that. Yeah.
or Mo 100 and Mo 99. Some of our investors refer to it as. But when you dig it out of the ground, 99 isn't contained within it. 99 comes from a nuclear reactor. So consequently, it's got a lot of dirty waste that has to be dealt with when it's produced. This has been the supply chain for the last 30 or 40 years. There's been no other way to get molybdenum 99. But our molybdenum 100, you can convert to molybdenum 99 or technetium 99 or other products at the point of care, right next to the patient, which means you haven't got this long, complex supply chain.
It sounds like it's going to be a product that people are going to, or certainly users are going to prefer to the existing one.
I'd like to think so, certainly. I mean, when you look at our plant, the headline capacity number is 20 kilograms per year. We're currently in discussions with potential customers for over 300 kilograms for the first 4 years. So the first plant, we have interest from customers for almost 4 times as much as the plant's headline capacity is. So I think there's going to be a lot of demand for it. Yeah, I mean, we're trying to expand the plant and make it bigger, and we'll do our best to fulfill customers' needs. But there's been a lot of interest in it.
And that would also presume that you're going to build more plants.
Yeah, we'd like to think so. I mean, there's a lot of isotopes that we can actually use this technology for. Historically, the world's largest supplier of isotopes has been Russia. So I think we're really going into a new kind of renaissance of isotope production around the world. There's a number of things driving that sudden change in supply-demand dynamics of isotopes. The first is the shutdown of these old nuclear reactors. That's going to take away a lot of supply. The second is there's a very large emerging use of new isotopes, things like silicon-28, zinc-68, for very high-tech industries. And the final thing is Russia and Ukraine. A lot of companies have put self-imposed embargoes on taking products from Russia. And as I said, they're the largest supplier of isotopes. We've had a lot of interest from potential customers for different isotopes. I mean, our carbon-14, for example, we have a single customer there who has a supply of carbon-14. We signed an MOU to supply them with enriched carbon-14 at the price of $24,000 a gram. That's a very high price for more than 400 times the price of gold.
So you've already spoken about Mo 100. Carbon is a bit easier on the tongue. So carbon-14, is that your second plant?
That's our second plant, correct. Now this was a pilot plant originally to enrich silicon-28. We'll talk about silicon-28 in a moment. But carbon-14 is used in the agrochemical industry and the pharmaceutical industry. You lace a new product with carbon-14 to see how it flows through the ecosystem and the environment and through humans. It's part of a requirement for developing new agrochemicals and new drugs. Historically, the entire world's supply of carbon-14 has come from Russia. It's currently not available. If you try and buy some carbon-14 now, it's not there. No matter what price you want to pay, you can't find it. We'll be able to produce the entire world's supply of carbon-14 from our plant here in Pretoria, starting in the middle of next year. Now, we took this silicon-28 plant, which was interesting in its own right. We have a lot of interest for silicon-28, but this plant is just not big enough to supply the interest that we have. So we thought we'll retrofit it and convert it to carbon-14, and it's likely our first new plant will be silicon-28.
That's interesting. So you've got... And I think for people listening to this and they're not scientifically minded, even they could understand that you've got this company that has got a pretty high-tech, innovative process, different to what everybody else has been using. Certainly when I spoke to Hendrik, I asked him, how come you're so clever? And he said, well, he spent 18 years developing this thing. And he did come from the Atomic Energy Corporation, which we know South Africa was an atomic power pre-1994. So I think we can all get it. You've got Mo 100 as a product, and there's 4 times as much demand for what you can produce at the moment. Now you've got another plant, silicon-28, which you've retrofitted to meet a demand for a product which just doesn't exist anymore because of Russia. And now you've got a third plant that you're looking at with silicon-28. Am I getting the story so far?
Yeah, that's right. So silicon-28 is really pretty interesting for the future. When you think about silicon, when you dig silicon out of the ground, there are 3 isotopes, so 28, 29, and 30. And if you think about conducting, if silicon-28 is in a straight line like that, silicon-29 is like that. And when you're trying to flow a current through the silicon, 29 blocks the current. If you can remove the 29, so everything's pointing in that direction there, your conductivity increases by hundreds of fold. So when you think about the future of quantum computing and high-tech electronics, people are going to need highly enriched silicon-28. So our goal is to be able to enrich silicon-28 to a level of 99.995%. That's very highly enriched. We're probably the only company in the West that can do that. We haven't done it yet, but we believe we can do it. And so I think the plan is to at some point build a plant for silicon-28, and we have a lot of interest from high-tech companies and governments about that product.
And what's the payback time on the building of these plants?
Well, I mean, something like silicon-28, the payback time is 18 months or so. The return on investment is very high. These are very high-priced products, and our feedstock costs are very cheap. So it's really just energy and people power is what we're using. So,
and the innovation, the invention. It's
something
that you've invented.
No one else can do this. It's been it's taken 20 plus years to develop. So And we don't actually have any patents on our process. We're controlled by the Non-Proliferation Treaty for Weapons of Mass Destruction and also the International Atomic Energy Agency. And so copying the process would be very challenging given the licenses and the licenses one would need from local nuclear regulators and the know-how and the ability just to run the experiments.
Warren Buffett always talks about a moat, and is that your moat?
That's our moat. That's correct. Yeah, we have patents on certain parts of the process. We're going to apply for patents on certain parts of the process. We have some very unique mass flow meters that one needs to use in the process. We have very special compressors. The process wouldn't work without those two items. There's also certain valves and pressures and things we can patent as well. So we're looking at all our IP at the moment to build as strong a moat as possible.
If you are a South African, you like the idea about the South African technology and you'd like to invest in your company, now that you've had an IPO, can we buy the shares on Nasdaq like anyone else?
Yeah, I think so. I think it just trades on Nasdaq like any other normal share. And so people can just buy the shares or sell the shares as and when they want to.
And from your perspective, why you? Why did you identify something that presumably many other people could have beaten you to the punch?
Yeah, I've been investing in science for the last 20 years. I'm a chemical engineer by training, so I actually understand what they're doing in terms of the chemistry and the physical separation with the forces that happen. So I understand the processing. I understand the markets because I've been involved in investing in healthcare for the last 20 years. For the longest I remember, there's been a problem with molybdenum-99. And if you read back at earnings transcripts from Cardinal Health and from Mallinckrodt, there's always supply problems. It's not in the right place at the right time. And I figured this could really solve that whole problem. So I recognized the opportunity, and I picked up the phone to a few friends, and we very quickly raised $4 million to go and bid for the asset in the auction. And then we've raised a lot more money since then to complete the asset and bring it to market.
And you've brought the business side or the investment side to an organization that was run by a bunch of scientists who I guess are not always commercially minded.
It's very common to find amazing scientists who aren't as good at running businesses or creating businesses. I've seen that consistently for the last 20 years. And what makes a really great company is when you combine great science with great business acumen and a great capital structure and great investors. You put all that together, and that's generally a recipe for success. And I think that's what we have here. I'm very confident that we've got some great science, we've got some supportive investors, and we have a great market opportunity.
But what about the next few plants? Because as an outsider, I look at this and think, okay, so you've got a process of isotopes. There are many different isotopes that you could be producing depending on how many plants you put together. Have you got a strategy to build more plants? And indeed, if you are going to, would you consider doing them in South Africa?
So we're talking to a number of different potential customers for other isotopes. We're unlikely to build a plant for an isotope without a firm offtake agreement from a customer that guarantees us a good IRR. I think they should be forthcoming. There's a lot of people who want a lot of different types of isotopes. So I think within the next 6 months, maybe we find that type of customer and that type of contract. Whether it goes in South Africa or not, we'll have to wait and see. South Africa has a problem with energy in terms of the supply of energy. We use quite a lot of energy. So maybe we choose another location where the energy is cheaper. It's possible also our isotopes may be produced for a government that may want the plant in their country. So we'll have to wait and see. But we've got a great team of scientists here, a great team of construction crew who's just built a plant. Even if we were to put the plant in another country, let's say the US or Europe or somewhere else, most of the plant would get constructed and built here and then shipped there and assembled there, essentially.
How ambitious are you? How big a company could this become?
Well, I don't get out of bed every day just to sit around and watch the company be average. It's going to be the best. And we're pretty motivated to make this the best isotope company in the world. We're probably the only listed company or only public company that actually enriches isotopes today, was able to enrich isotopes for commercial activity today. Listen, it's a really exciting opportunity. And that's what gets me out of bed each day to come and push forward and make this company great.
Paul Mann is the chairman of ASP Isotopes, a company that was built in Pretoria, I'm Alec Hogg from BizNews.com.